It's a real honor for me to be here, it really is. It means a lot that I've been asked to speak. A little bit intimidating, so many of you people here. If you find me difficult to understand, that's because I'm from Liverpool and I don't speak properly. So tell me to slow down and I'll slow down. Or I'll speed up if you prefer me to speed up. So I'm going to kind of touch the subject of generative audio and generative music. It's something I've done a lot of work in. I've not been able to publish many games with it in because it's quite hard to convince publishers to do something a bit different, and that's part of what we'll talk about. I'm quite old now. I feel old. So I've been around in the industry for almost 20 years and published about 40-odd games as a combination of a composer, sound designer, audio director, anything. If they pay me money and it's audio, I'll do it. That's how it works. My current gig is with Microsoft in London. They have a studio called Soho Productions, which focuses more on television production. And if anyone's got an Xbox One, does anyone have an Xbox One? Yes, there you go. Okay, a couple of people. There's a service on Xbox Live called Upload, which is a game video sharing service. So I've been heavily involved with that. As it says down there, I'm also working with Hello Games on No Man's Sky. Have you heard of No Man's Sky? Oh, a few people. Okay, good. Okay. I'd love to tell you a lot more about that project, but I'm not going to. And I spent a couple of years on Thief, against the audio director, composer, and sound designer. This was 2 years ago. I quit. So if you've played the game, it's not my fault, right? I have nothing to do with that game. I'm sorry. All I can say is, But there's still quite a lot of, I think, my music in that game. So I believe, but I refuse to play it. I am not playing that game. It was an interesting experience. I do a lot of work with a company called The Sound Agency, who are a very interesting audio branding company. So they don't make games. What they do is they work with advertising agencies, with shopping centers and places like that. And we will sound design space in a very kind of game way. It doesn't sound like a game, but it uses game technology. So, for example, one of our big jobs was sound designing Harrods in London. So it's various parts of Harrods which have generative music and generative sound design. People don't know that. They don't need to know that. But the point is it's sympathetic to the space. I'll go into a bit more detail about that as well. OK, so some of the questions I'll try and cover. What do I mean by generative audio? And I'm going to blur the line a little bit between procedural audio and generative music. So I'm just going to kind of combine them. It's a bit wrong to do that, but that's what I'm going to do because I don't care. And I'm going to talk about how we can make it relevant for games, and indie games in particular. So it's all very well having really cool technology, but it has to be practical. It has to offer real benefit to people. That's hopefully what I'll try and show. And there'll be various examples on the way. Terminology is a problem. So people like Andy Farnell, if you've ever come across procedural audio, you'll have heard of Dr. Andy Farnell. Actually happens to be a friend of mine. He talks a lot about how you can use things like pure data, which is a programming language, to construct synthetic models of sound. So that tends to be what he means by procedural audio. So a very simple example of that would be so that sounds a bit like a violin. It's not a violin, it's a synthesizer, right? But it's kind of modeling the sound of a violin. So that's what a lot of physical modeling is about. And that's a very interesting area, modeling sound effects, rather than recording, sampling sound effects. We'll touch on that. I'm more interested in kind of the emergent side of things, which is using simple logic to create interesting and appealing music and sound design. So much in the way that you can get complex behavior in AI, I like applying that idea to music. I think there tends to be too much focus on the technology and creating clever algorithms, and not enough attention on the aesthetics. Is it an interesting piece of music? Does it work with the game? Does it offer actual benefit? Sometimes people call it adaptive music as well. Adaptive music tends to mean having pre-recorded linear music, but you move between different stems, different elements of it. So you can never create something new, you're just basically mixing on the live. So I'm not as interested in that. I think it's easier to say, what are the elements that drive generative audio? So I've attempted to come up with a really bad definition. It's not great. But some of the key elements are, there has to be a machine processing involved in it. It inherently involves this idea of controlled randomization, of being variable, of being flexible. And something I like to refer to is for it to be believable. I'm not interested in realism, unless I'm making a simulation. What I want is for the player to be immersed in the game, enjoying the game, and not to be taken out of it because the sound of the music is distracting for them. Okay? So it's about creating an environment that they feel comfortable with. So believable it's a bit boring, but it's a word I keep coming up against. Or authentic. So if someone says to me as a sound designer, I want that spaceship to sound real. Well, spaceships don't sound real because they don't exist. Right? What you want is your audience to believe it's a spaceship. And that's what a film sound designer will do. There are quite a few existing tools already. A lot of people do use pure data. There's Max MSP. C-Sound is something I'll show you a little later. In the game world, those technologies are not ideal because they're not built for real-time, runtime. They're not optimized. You have got libpd, which is a mobile version of pure data. That works very well. But if any of you remember a game called Spore, that tried to adapt pure data. And I know it took them a lot of time and a lot of programmers, and therefore a lot of money, for actually not that much benefit. They would have been better just writing it in C from the beginning. And there's loads of fun Android and iOS apps as well. But what I'm going to show you is technology that we've built specifically for the kind of jobs that we do. However, I do have a little video now, and this is just going to show you some examples of the software. The first one is by a company called Audio Gaming, and it's about simulating weather effects. It's great that they're doing this. I'm not entirely convinced by it, but you'll see it. There's Nodal, which is a plugin, VST plugin, which is about MIDI, generating generative MIDI. And the last demonstration I think is, for me, the most interesting, is using some software called Impromptu, which is a live coding environment. And it simulates a kind of Keith Jarrett-style piano playing. Okay. So it's playing wind, but they're very noisy, so you can't hear it's wind. There we go. So all those 3 examples show you computer-generated music, essentially, or computer-generated sound design. So we want to take an element of that and try and incorporate that into game design if we can. There's one quote I use a lot by good old Brian Eno, because I think it sums up what we're trying to do here. And if you can see that, it says, I really think it's possible that our grandchildren will look at us and wonder and say, you mean you used to listen to exactly the same thing over and over again? And I think that we have that mindset for game design, but I don't think we all yet have that mindset for the audio design in games. As always, procedural generative music is not a new thing. There have been attempts from the beginning of game publishing. You're probably all too young, but there's a great game called Ball Blazer, or Ball Blaster, by Lucasfilm, and that LucasArts. It was their first ever game. And that had a generative melody in the theme title. I've got a video of that. There's Monkey Island, which had a fascinating interactive music system called iMuse. There's a little game I worked on years ago called Ghostmaster. We didn't tell anyone it had a generative music system, but all the in-game music was completely randomized using small components. And then there's Spore. So I've got, again, some short video examples. So as an audio director, if I'm going to try and convince a developer to use a generative system, there are certain rules I have to play by. So this is like the first stage. Yes, you have to design the system, but you have to convince them. And so these are kind of like the key rules. Whatever you build has to be efficient. Doesn't matter how much CPU you've got, how much memory, efficiency is always there. And that means memory usage, it means CPU usage, bandwidth. For example, Unreal is a great 3D engine. It's bloody lousy for audio people, because it loads all the assets at the beginning of a level, then streams all the textures, and it's very hard then to stream audio data as part of that. So you need to understand what the engine can do. As a general rule of thumb, audio gets between 5 and 10% of total CPU time. Depends on the project, depends on the game. But certainly in terms of console development, you're looking at about 5 to 10%. For PS3, 360 development, about 30 meg of memory. It's a bit too early to tell for next gen. And I've got to argue that whatever engine I'm going to give them has real benefit to the title. It has to be something I can really realize, it has to be practical, it has to be fairly short development time, because people aren't going to spend a lot of money on audio, and scalable. So if it works, we build it bigger, and it's able to get bigger. So I'm shortly going to show you one of the engines. The challenge that we have, and I won't spend much time on this, is that we're very sensitive to sound. Everyone's very sensitive, more sensitive than we are to visuals. So it's hard to trick the ear that what we're listening to is authentic, is at least believable. And so a lot of what I try and do is try and convince people that what they're listening to is real music, but actually it's kind of computer-controlled music, right? And you're using every trick you can to do that. And you really want to, as a sound designer, be part of that game design process as early as possible. But I think the justification for doing generative music, so having a system that is random and it's flexible, comes from this Kotaku article. It's over a year old. But it's interesting because it kind of sums up from a game player's perspective some of the problems they perceive about playing games. Your game might be greatly non-linear and it might have some fantastic tech, But if you're hearing the same bit of music every single time, or the same music is looping all the time, then you've got a conflict, right? You've got the music doing something different to what the game is doing. So we're trying to merge the two of them. So if you haven't seen it, I'll just show you that No Man's Sky trailer. So I'm sorry, I can't talk more about it. But you'll see that a game such as No Man's Sky is a really good motivator for trying to have an audio engine that does more than just play linear music, play loops. So this is the trailer that they showed at the end of last year. So my involvement in that was with the sound design and the mixing. I didn't like the music on that. That's all they've revealed about the game. It's very interesting, but you can see that if the gameplay, if the environment is all procedurally driven, you know, we have to have sound design that's procedurally driven. So the questions we have to answer. I'm going to move on a little bit. Okay. I'm going to skip this one to save a little bit of time. I'm going to show you one system we built. This is the system we built for Thief. This was shown at GDC a couple of years ago, so I'm allowed to show it. I don't care. I know that they didn't use it in the final build. After I left, about a year and a half after I left that project, I got a call from IDOS, because I still speak to them. And they said to me, we've got this new game called Thief. They obviously didn't know who they were speaking to. And it's got this music, and it's in some strange format, and can you do anything with it? And I said, well, probably yes, because I wrote the format. You know, this is just madness. So after I left, it turns out they wanted to use all my music and sound design anyway. It was a complicated project, but the system is quite nice. So we're using Wires as the audio engine. So we don't have to build our own audio engine. Wires will get the sound out. It's a very flexible audio engine. We had effects and so forth to it. So that controls all the I/O stuff. We don't worry about that. What we wrote in C was some logic to sit on top to control the playback of samples and the music logic. And actually, it's a very straightforward system. Each of these is effectively a channel. You can't see it, can you? You're looking at me blank. There you go. There you go. That helps. Each of these is a channel. And you can populate these channels with a group of sounds. So, for example, it could be piano phrase, or it could be bass, or percussion. That's up to you. And it could be one phase, it could be one sound, it could be 1,000. Doesn't matter, they're just groups, just lumping them together. But within that, what we can control are things like how often an event gets triggered over time. So it's simple randomization. So if this is actually in beats, so I can say that first one, a sound has to trigger within 18 to 28 beats. So if we're in 4/4, divide by 4, you'll get the number of bars. Polyphony, how many notes can play at the same time. Spread, if it wants to play more than one note at the same time, it can move them apart. So we can control it that way. And various other small features in there. The scale rules we have over here. So written in XML is a really simple structure where I can define what scale it is. Not what key, because a key is irrelevant, as long as the piece is consistent within the key. But I'm interested in how many notes, what kind of notes in the scale, rather. Major, minor, Aeolian, Dorian, and so forth. So that's represented in the XML. You don't see it in here. The cool thing about this was that you could create a piece of random music, include all your events, and create a different state. And then you can morph between the states. So the idea of that would be you could start a level with one piece of ambient music, and as you move across your level or as it evolves, you can transition to another piece without the player ever being aware that it's changing. So values just slowly step through. And it might possibly, if I can, there you go. If I do it manually, you can see it, how it moves. There we go. And different events can step through at different rates. So you could have ambience slowly coming in. You could suddenly have a melody coming in when it wasn't before. So it was a simple solution. I'm not that technical. I'm not a programmer. So for me, this was just a simple solution to get something which was more flexible and sounded a bit like the old Thief games in terms of being very ambient. Okay. So the next system I will show is called the Amberfire, and that's the system we use for our commercial installation work. And it's stating the obvious to say that the sound we hear in space affects us. I mean, clearly it does. However, it's astonishing how many companies, how many big brands, how many shopping centers and banks don't understand that if their space doesn't sound appealing, doesn't sound nice, it's too noisy, that's going to affect us. We're not going to feel comfortable in that space. So if you go to a supermarket and you've got the refrigerators buzzing away really loudly and those trolleys that always squeak and doors slamming, even subconsciously you're thinking, I don't want to be here, I'm not comfortable in this space. So a lot of the work I do with a sound agency is to try and make people feel calmer, happier, wanting to spend time in space. Now, the flip side of that is if you are happier and spend more time in, say, a shopping center, you will buy more. Okay? That's the way it works. Now, that's not necessarily a bad thing, I'm just saying that's what we do. And in fact, we did an early test at Glasgow Airport, where I literally wrote music for the airport at Glasgow. And we had one day of generative ambient music, one day of no music at all, and we rotated for 2 months. On the day that they had ambient music, their sales increased somewhere between 5 and 10%, which is an astonishing figure. Now, it's a particularly good figure. Airports, people feel stressed, they're nervous, they want to relax, so the music clearly helped in that. But it's just indicative of some of the benefits that appropriate music and gentle music can have. Another example, and I'm not entirely convinced by this, is we wrote a piece of music that was played in an American town, and now the mayor claims it's crime. So brilliant. So I get people to spend more money and to commit less crimes. What a fantastic career I have. I don't entirely believe this, but anyway. So what I'll do is I'll show you our Amberfire system, because I think it's an interesting, different approach to creating a generative music system. I've talked a lot about this. There's certainly something in using what's called stochastic sounds as well. So those are sounds like wind, water, birds, which are repetitive, but there's always a bit of a difference. There's always variety, and they're familiar. So we don't like total silence. That's disturbing. And even though it's a cliche, if you put on some bird song, it kind of feels nice. Right? It kind of feels pleasant, you know. So it's not to say that we need bird song in all our games, but you might want to replicate or tap into that element that our brains like certain sounds or certain psychoacoustic elements. We ran another test with students where we played them the ambient noise of a cafe, commercial music, and ambient music that was generative, but point was it was ambient music. This is from a paper that's not been published yet, so it's not quite come out yet. But it's really interesting because the mean value, which is how people are feeling before the test, was 5. So you're starting from a baseline of 5. With the ambient cafe noise, it's just a little bit below 5. So a bit less appealing. People feel a little bit less negative about it. Sorry, rather a little bit more negative, a little bit more stressed, but not much. Music, interestingly, is the worst. People felt most stressed and most uncomfortable listening to commercial music. But with the ambient music, you can see the figure is dragged down there. That gave a better number. People felt more relaxed, more comfortable, calmer with ambient music. Not a surprise, but it's very hard to get this kind of data, and it's nice to see actual hard data on how people are reacting to this. So as an example of what we do in terms of spaces, you don't have to read the text, it's fine. But that's the toy department of Harrods as a plan. It's much like a game level design. Right? A lot of what I get could be, especially when it's a digital file, And what I did was map out the music and sound design through that space, right? So for me, it's irrelevant if it's a player or a real person. I don't care. It's the same effect. And as people are moving through the space, I want to give them kind of different stories. So, for example, as they come in at the bottom end, that's like the library. So that's nice and calm. Lets people read the books. There's not much going on. If they go into the space zones, that's great fun. Lots of bleeps and things going off, all of which are randomly triggered. Then they go into like this enchanted forest, so that's like a Harry Potter style space. And there's point sounds in the space as well. So if you listen to a flower pot, for example, there's a little fairy in a flower pot, as you do. And that will randomly trigger lines of dialogue. So you can see how we're kind of interpreting real spaces as game spaces and using a similar design approach. So let me just show you our system there. No, I've lost it, of course. So this is the code behind our Amplifier system. An actual Amplifier is a Linux rack, but it's entirely cross-platform. So this tech will obviously work on Windows, Mac, it works on anything. It's based on C Sound, which is open source. So all this stuff is open source. And we've written our own modules for C Sound. What's interesting is that the logic for the music is in one file, which is all this file. And the actual assets, let's do this backwards, sits in another file. So where that's quite cool is that you could write entirely new logic for a piece, and then the C-sound reader element will just accept that. So you might design one piece of music to use like chord generators, and another one to use, say, a beat generator. But you don't have to rewrite the system, you just rewrite the logic, and the system will interpret it. So that's a great and interesting approach for games, that you could have a new level and give it new logic on a new level if you wanted to. But because I'm a relatively simple person, I like simple things. So I feed it samples, and these are all small phrases, little melodic phrases, single notes that can be combined into chords. And then I glue them together at the bottom. Here we are. And like with that previous system, all I'm really saying is the likelihood of one sound from a group being played over a unit of time. But the effect you get when you combine it all is in a sense, greater than the sum of its parts. The challenge as a composer is to be able to write that way. So you kind of write music backwards. You can't write a finished piece. You kind of write the components, and you have to be very hard on yourself and move things around and say, does it still work? Is it going to sound logical? So I will fire this up. Oh, well, that's nice. Obviously, it's failed to work at the time. Why? Why? All right, give me 1 second. It's going so well. There we go. It takes a few seconds to come up to speed. So it just plays a gentle, calm. Sounds like someone's going to the toilet, but it's not. It's quite hard to demonstrate this because you have to listen to it for a while, and then everyone falls asleep. Okay, so this is actually for a shopping centre in Estonia. It's something we're working on. But you get the idea how the component parts kind of fit together, although where and when they play is random. One of the cool things I will show you, because it's relatively new, as we're trying to make it more and more generative, is we have this idea of, it's almost like an LFO in synth terms, an oscillator. It's not quite an oscillator, it's kind of an oscillator stroke envelope. And it has a hold time, a static time, a ramp up, sustain, ramp down, sustain time. But those times are all randomized through minimum and maximum, which I define in the piece. And we can use that as an oscillator to drive anything. So it could drive, say, the pan. So it can move one instrument on one side, or one set of instruments. We can then use the negative value to move other stuff to the other side. So that's quite useful. Or we can use it to control density. So you'll get these moments where more things will happen than less things will happen, and this kind of ebb and flow. And you can set up as many of these oscillators as you want. The next stage is, we haven't got it in this version, but to put in a chord generator, which has a similar kind of approach. So sometimes it'll play lots of chords, sometimes not chords, sometimes arpeggios. We can control that. Now I have to get back to PowerPoint, and that's going to be really hard. There we go. So, really where we're up to, I'll take some questions in a minute, is I'm very interested to try and connect the music and sound design much more closely with the game. And I know that it's very hard because often you don't have a skill set to do the audio, or you leave audio towards the end, or there's not enough money. And it's a challenge. I know it's a challenge. And I love working with indies because you get to have a lot of creative control. I like that a lot. But to think of it as a whole is really useful. There's a little game I did called Finger Hula. It's on iOS and Android. And you basically just spin hoops. But the hoops control the chords. And we couldn't have done that without designing the music system as part of the game design, so one in a whole. We have to have a system that's variable enough to make it worthwhile to develop. Otherwise, what's the point? Just have long WAVs that we can loop. It has to be memory efficient. So it doesn't matter what platform we're on, memory is always an issue. If you've got procedural gameplay, then clearly we need to tie into that procedural gameplay. And it has to be convincing. A lot of the synthetic sound effects I've heard are not entirely convincing. And with audio gaming and with Wise, the audio engine, they both have these kind of wind and rain demos, or certainly wind. You know, it's white noise. I don't need to spend, whatever, $500 on a plugin to make me white noise. No offense to them, I think what they're doing is great. I've recorded lots of wind in my life. Okay? I love recording sounds. I've got whole libraries of wind. Wind with real character, with texture. And I know, I mean, it sounds silly, but you know, wind and whooshes, you can't go wrong as a sound designer. I know I've got certain wind and certain level that will fit beautifully. Right? I'm looking for that aesthetic quality. And I don't think we're quite at the stage where synthetic models are offering that aesthetic element to it. And you don't want to do it for everything. It's not always suitable. I'm not saying that everything should be procedural. I think what it needs is that one game to be a breakthrough game where it is procedural gameplay, it is procedural audio, and the two work together, and then that can act as the demonstration. Obviously, I'm hoping No Man's Sky will be that game, but we'll see. So I've largely talked about that, and I have some links at the end. So one of the things I'll just very briefly touch on as well is I'm very interested in the idea of structure. So music is the most structural of all the arts, whereas with something visual, we can absorb it all in one. There can be multiple layers, and we can enjoy it in different ways, but we can see the whole structure. Clearly, with music, we can't. So we could have beautiful mathematical structures to describe the music, but we're not going to understand that unless we listen to it over and over again. So that's one of the challenges as a composer, that we want the structure of music to fit the structure of the game and to work over time, and yet still work as music. Right? And that's not an easy thing to do. Right? So we're kind of working with multiple challenges. There's technical, there's creative, there's aesthetic. But the feeling I get when we talk to people about generative music now, a few years ago, that would be seen as something really weird. Right? They wouldn't have a clue of what we're talking about, particularly if we're talking to an advertising agency. Now it's like, yeah, okay, great. You know, music that changes over time, I get that. You know? So there's a kind of acceptance now. And I think things like iOS, I'm not a great supporter of Apple, but our attitude of shuffle, of living in an app world, I think that's helped that attitude that things can be granular and modular, and that's okay. No, it's legitimate. I've got maybe 5 minutes to answer any questions. Does anyone have any questions? Yeah, you have to shout really loud.
Test, okay. Well, I was just wondering if there's a composer working on a game. Does he work with the same engine, the modeling engine, which is in the software of the game? Because then he can provide only with sequences, MIDI sequences, and the modeling engine will play them, and it will be altered by which level you play in the game.
Okay,
So it's different from playing samples. So does the composer need to have the same engine then to compose with?
So the question is, does the composer need the same engine, audio engine, to compose with? And as a general rule, I say yes, they do. In the same way that as a sound designer, you need to have builds of a game. There are sound designers who do work for whatever reason without getting the builds. That's impossible, right? Because you don't know what's happening, you don't know how long the sounds need to be. They're not integrating. You're just creating stuff that you hope is going to work. That's not good enough. Right? You can't hope it's going to work, you have to know it works. So wherever possible, for example, Audio Kinetics Wise audio engine is great for that. And you can build these, what they call RTPCs, real-time parameter controls, from the game engine into the audio engine. So you can say, I don't know, this level of me being attacked, that has a value. I can quantize that value and then attach it to something completely different. I could attach it to music intensity, I could attach it to a sound, I could attach it to how much of a whoosh there is, whatever. And obviously if it's synthetic audio, then you can open that up, and any part of that synthesizer could be attached to that parameter. You don't want to go crazy, because you will drive yourself mad. You want to keep it controlled. But yes, I mean, so that level of connection, I think it's really worthwhile doing. Yeah. Any other questions? No, have I totally confused you or put you to sleep? One of the two.
Here we go. As a composer, there's a lot of mixing and mastering you need to do as well. But how would you do that when you don't even know what's going to come in advance, since the music is being generated at the moment itself?
Yeah. So it's a really good question. How do you mix in a generative environment? It's not entirely easy, but you kind of know what your peak is and what your bass is. With something like C-Sound, I can render out as long as I want. Very, very quickly. So I'll often render half an hour, and it takes a few seconds. And then I can quickly go and see what the two, the highest point, the loudest point, the quietest point is. And you mix in engine, effectively. You say, this element can never get any louder than this. And then stick a limiter right at the end just to control it so you don't get any distortion. But it's not easy. You will get those moments where you think, what's happened to the music? It's all gone. Well, that's the nature of the system, I'm afraid. You have to give up some of that control. Any other questions? Or we're all done? Okay, I hope that was of use. Thank you very much for listening to me. See you afterwards.